Hello everyone, my name is Bhavish Lohar and I welcome you on my YouTube channel Quest Achiever. So we have completed with the combinational circuit. Now we are back with the sequential circuit. So in basically we complete with the mux and demux, which are the last topic of this combinational circuit. Now we are basically continuing this sequential circuit of digital electronic series. So in that, basically the difference is that the combinational circuit will depend only on the present state of input, while sequential circuit depends on both present state and the previous state of input. So whenever a circuit designed in sequential circuit, it will hold the previous input also or data. Okay, so here we'll take an example of sequential circuit like latches, flip-flops. These are the example of sequential circuits. Okay, so latches, I will make a circuit which is a sequential circuit, that is this is also basically a sequential circuit, that is called as a latches. Okay, this is a bistable multivibrator also. This circuit is also called as a bistable because if you give 0 over here, you will get 0, because this is a NOT gate. This is a NOT gate. NOT will always invert the output. Means 0, it will provide you 1. 1 will provide you 0. So 0 will come here. If you give 1, it will give you 0, it will give 1. So bistable, only 1 and 0. It will hold that input is same as that output. So it is holding the 2 bits. Whatever you are giving input, that only the output will be there. That's why it is a bistable multivibrator. Okay. So this is also a circuit which is called as a sequential circuit. So we'll study basically latches, flip-flop and counters, okay, in this sequential circuit. Okay, now I will take one example of latches, that is using NAND gate SR latch. This why we are studying, because this will help you in analyzing this flip-flops, because flip-flop is one of the major topic, or we can say basic or good topic for the exams. Okay, so this is SR latch. Okay, this is SR latch using NAND gate. Now what we are doing, basically we'll see that what will be the output of this. Okay, always there will be a complement of the output. If there is a Q, then here will be a Q dash. Okay, that means you are getting the output of this is Q, then here will be an output will be the Q dash. Always the complement output will be there in latches. Okay, see here I am getting Q, then here I will get the basically Q dash. So in latches we will always be getting the complement output. Okay, similarly flip-flops, this is the basic circuit for getting the flip-flops. Okay, so latches give you flip-flops and flip-flops gives you the counter. Okay, so using flip-flops you will get, so step by step we will go ahead and we will study each and every circuits. Okay, so I am starting from the scratch, that's why we will study the basic thing and then we'll move ahead with the flip-flops also. So suppose the input is 2 inputs, so 4 combinations 0 0 1 1 0 1 0 1. Okay, now this is Q and this is Q dash. Okay, now you all know about the NAND gate. I already taught you regarding the NAND gate. You can watch my previous video also regarding the NAND gate. So any of the input is 0, it give high. So here you will get 1. In this also you will get, because the input is 0, irrespective of the second input. Okay, it will always give you high only. Okay, then basically here second input is 0, it will give 1. Okay, now basically here you are getting 1. You can solve it out, it is not difficult. Okay, so now you are having 1 and here also 1 and 1 will give you 0. Understood? here you having 1. So first see the 0 where you are getting the 0, because any of the input is 0, it will provide you the 1. So now this NAND gate is getting 0, so it will provide you the 1. So then it will always give you the complement of this. Then 1, then it will give you 0, and here will give you 1. Understood? Then now last is what? This is suppose 1, this is also 1. Now this is what? This second input is what? Q dash. This is Q. 1 multiplied by Q dash gives you Q dash only, but okay, then finally it will give you Q only. Then this will Q and this will get the Q dash. You can solve it out, simple, nothing complicated. Okay, getting me or not? So what we have studied, that this should be, see, in this case both are same, but in rest all 3 will have 1 0 0 1 Q dash is there, but this is the same thing. This condition is called as the invalid condition. Invalid condition happen because we want a complement output, not the same output. That's why it is an invalid condition happen in the SR latch. Okay, this circuit is also called as SR latch. Getting me? So this is the one of the invalid state happen in this case, in this circuit. This will help you, because why we are studying this, first of all, because this will help you in the one of the flip-flops while we're studying the SR flip-flop, JK flip-flop. There we'll come to know about what is the invalid condition. Okay, so this is the basic thing what we are studying. Just understand how I am getting this thing, and the truth table is really important. Okay, so what we have studied, again, sequential circuit. We have studied differentiate the difference between the combinational and the sequential circuit. Then we studied the type of sequential circuit, latches, flip-flops, and then counter. All are these are sequential, come under sequential circuit only, and we took some example of this also. This is latch only. Okay, basic latch element. Okay, basic memory element, and this is also SR latch. We have studied and we have given some input to this latch, and we got some conditions. This is the valid conditions, because we are getting the complement of the output, but here we are not getting. This is called as a invalid condition. In this case, basically this condition is also called as racing or rising problem, because in this condition is also called as invalid state. This is a problem in latches, also called as racing or rising problem. Okay, so I think this much is clear. Okay, in next class basically we'll study the flip-flops. That is the quite interesting topic, and one of the question definitely will be there in the exam, in any of the exam. Okay, the sequential circuit is clear, and we took some main points whatever we want. Okay, now we'll see the flip-flop in the next class. We'll start with the SR flip-flops. There are 4 flip-flops we'll study. Okay, we'll study now. Okay, till then, thank you so much.